Now, to check what we have learned about the trend in terms of atomic radius, let's try comparing some. So, if I am to compare which atom is bigger between zirconium and, say, for instance, silicon, all I have to do is to remember the trend. No? Since atomic radius determine the size of the atom, I can check first if they lie in the same period, because the period would tell me the number of shell, and obviously the bigger the number of the period, the bigger the number of the shell, the bigger the atom. Hopefully that makes sense. So zirconium and silicon does not lie on the same period. Therefore, silicon has only 3 shells while zirconium has 5. Obviously, zirconium would be much more bigger than my silicon. Now, sir, what if they lie on the same shell? No, they lie on the same period. So, that's the time we'll use the other trend. Say, for instance, zirconium. That would be compared to silver, sabihin natin, which one is bigger in terms of atomic radius or in the size of the atom itself. Now, by concept, as the number of proton increases, that's going to the right, more the electron is being pulled towards the nucleus, making the atom a bit smaller as compared to the previous atom. Therefore, zirconium would still be bigger than silver. Hopefully that makes sense. So the trend would be top to bottom. So yung paganto, zirconium is bigger. Top to bottom, increasing. And then left to right, right to left, still increasing. So the atom, para mas madaling tandaan, the biggest atom is francium. So francium is our biggest atom. That's the first trend, the atomic radius. Now we go to the second trend, the ionic radius. So what's the difference between atomic radius and ionic radius? Of course, atoms and ions are different. If you can still remember our discussion on ions are charged atoms, slightly charged atom. Our cation and an ion. So we talk about the cation and an ion. So cation and an ion. What would happen if an atom becomes an ion? So let's take sodium chloride for example. Sodium for my cation and then chlorine for my anion. Sodium initially, let's move yan. Sodium initially is in period number 3 with 3 shells. So that would be Na. So dito ko na lang ilagay 1, 2, 3. And then since I remove this valence electron, the shell will be gone. So what happened to my cation? This now becomes my cation. My cation becomes smaller as compared to my normal atom or neutral atom. So ito na lang tuloy yung neutral atom. Ito na ang aking cation. So removing an electron makes my ion smaller rather, as compared to the neutral atom. But let's take a look at our anion. Chlorine is in number 3, period number 3. So 1, 2, 3 shells. That's 3 shells. And then it has 7 valence electron outside dito. 1, 2, 3, 4, 5, 6, 7. So it will gain an electron. So initially, the proton of chlorine is 17 and the electron is 17. Adding 1 electron to make it an ion will make my electron 18. Therefore, the 17 strength will be divided into 18 electrons, making this shell move or expands a little bit or loosen up a little bit kasi hihina yung paghila nila. Can you imagine it? So, this will become slightly bigger. So, magiging ganyan siya. Hindi siya nagdagdag ng shell, probably this will be the adjusted shell. No? And as we increase, if we add more numbers, meaning halimbawa, we'll be using sulfur, that would be S2 negative, the protons will have 16 protons will pull 18 electrons. So they will be they will be dividing their strengths just to pull these electrons which are adding up. So that's our ionic radius. Cation will become smaller, anion will become bigger. So remember that. Our third trend would be ionization energy. So our third trend will be ionization energy. Now what do we mean by ionization energy? So ionization energy is simply the energy needed to remove an electron or to ionize an atom. So question, what do you think will be easier to ionize? Francium or helium? If you answer francium, you are actually correct because francium has 7 shells. So Fr, let's count 1, 2, 3, 4, 5, 6, 7. And within these shells are 8 electrons except the first shell. So madaming electrons, and on the last shell there is one lonely electron which is probably already being ignored, no? That's why maybe if this is the source of energy, with just my pinky I can easily grab this electron without the francium even noticing it. No? So I only need a very little amount of energy to ionize this one, to release this one. So the ionization energy in francium is very less. Now how about my helium? So as compared to my helium, no, the helium is hugging tight these 2 electrons. Therefore, I cannot pull it with my pinky. Or probably, again, analogy lang to. If I'll be using my bare hands or my whole hand, right hand, I still cannot remove it. Maybe I can use 2 hands, 3 or 4, meaning a lot of energy is needed to remove this one. Same with comparing francium to lithium. Therefore, as we go up, now the ionization energy increases. Now, how about from left to right? Now, comparing lithium to fluorine. Now, fluorine would want to gain an electron rather than lose it. Therefore, the ionization energy here is increasing. So, for the ionization energy, the trend would be like this one. Increasing from bottom to top. So, increasing. And left to right, increasing. So, in shortcut, ganyan siya. So, that's the opposite of the atomic radius. The ionization energy. Meaning, the smaller, if we will compare them now, the smaller the atom, the harder it is to remove an electron. Sige, let's put that into practice. Say for instance, I'll be comparing the ionization energy needed to remove an electron from nitrogen and then gold. No. Comparing their periods, gold is in period 6 while in nitrogen is in period 2. Therefore, gold has less ionization energy needed while nitrogen needs a lot of ionization energy. Let's compare elements within the same period. Say for instance, hashum. Diba? Ang lemon is mahashum. Char lang. Hashum and then uh, moscovium. No? Alin dito yung mas madaling tanggalan ng electron? No? Meaning, which one needs less ionization energy? And looking at our trend, no, hashum needs lesser ionization energy as compared to moscovium. So that's how we use periodic trend to check their properties. So that's our third one, ionization energy. Hopefully that's clear. Later on, I'll be giving some practice problems. Alright. For the fourth one, we have the so-called electron affinity. Electron affinity. What do we mean by electron affinity? Electron affinity simply means the ability of an atom to attract electron. And by that definition, do you have something in mind? Obviously, the one that are attracting more electrons are the ones that are on the left side. But before that, let's follow the trend. No? Let's stick on how do we check the trend. So say for instance, we are to compare lithium once again to francium. Which one do you think will have stronger attachment to its electron? Which one will be hugging its electron tightly? Francium, as I've mentioned a while ago, is very the last electron of francium is very far from the nucleus. Therefore, the francium's electron affinity is very low as compared to the lithium, which is very close to the nucleus. So for visuals, again, this is your lithium. 1, 2. So malapit lang yung mga electrons niya. So it's strong. Fr 1, 2, 3, 4, 5, 6, 7. He cannot get a strong hold of all of these electrons. So the electron affinity is low. Therefore, the trend would still be increasing from the bottom to the top. Now, how about from the left to right? We learned in our compounds and ions that gases tends to accept electron and hold their electrons rather than release them. Therefore, that's their electron affinity. Their electron affinity is very strong as compared to our metals, which can easily release electron, making our metals reactive, very reactive in particular. So therefore, the trend would be going this way. So increasing and then also increasing. So papunta rin dito. That's our electron affinity. So if I am to ask you, which one holds its electron stronger? Chlorine or yttrium? So from top to bottom, that would be increasing. Different period, 5 and 3. Therefore, chlorine will hold its electron stronger as compared to yttrium. Let's compare elements on the same period. So, sabihin natin ruthenium and then iodine. So, which one will be stronger? Or will have a higher electron affinity to its electron? It would be the iodine. It will hold its electron stronger as compared to those at the left side of the periodic table. So that is your electron affinity. Very similar to ionization energy because they go hand in hand. So, ganun yung trend from bottom left to bottom right. if you'll summarize it. Now, for the last one, our last is electronegativity. Electronegativity. Si electronegativity is just a consequence of ionization energy. Now, they are very, very similar. Electronegativity trend would be from top to bottom, from bottom to top, and then left to right. So that's the uh, ability to either to release an electron and gain an electron. So let's summarize the trend. Let's simplify the different trends. For atomic radius, the trend would be, as we go down, it becomes bigger. So increasing ang trend natin para hindi malito. And as we go from right to left, increasing. Or the summary for atomic radius is this one. While the exception dito sa arrows natin, si ionic radius. So lagay pa rin tuloy natin dito. Ionic radius. Example na lang natin. Na, the size of Na would be greater than the cation. Size of chlorine would be less than the size of an anion. So hopefully this example makes sense, no? Or atom na lang, greater than cation but less than an ion in terms of their ionic radius or ionic size. Then we have the ionization energy. We have the electron affinity. And then we have the electron negativity, which all goes from top to bottom. So increasing. And then left to right, increasing. And yan. The trend would be like that, like this one. So hopefully that makes sense. This is the summary of the periodic trends. So let's now compare some of the elements in terms of atomic radius, ionization energy, electron affinity, and electronegativity. So take note of this and submit it when you have your internet already, your power and internet already. So let's compare La, copper, sulfur, lithium, Lv, and then scandium. So arrange these 6 elements in terms of atomic radius, electron affinity, electron negativity, ionization energy. So that's it. There you have it. All about periodic table of elements. Should you have any questions, please comment down below, or you can message me via Facebook, because once again, still don't have internet at home. Thank you so much, and that would be all. See you on the next episode of the Academic Adventure. Bye-bye.